Good morning, guys. This is your Dharmesh sir. So today, one more important chapter we are going to discuss, that is carbon and its compounds. So you all know that this topic is very new to you. You need to focus more and more on the topic carbon and its compounds. I will explain you each and everything related to this topic in detail. So kindly focus how we are approaching the concept carbon and its compounds. First, let us go with what kind of topic is this? Carbon and compounds is what kind of topic? So this particular topic is belonging to organic chemistry. It is belonging to organic chemistry. So what is organic chemistry? Organic chemistry, it is the study of organic compounds. It is the study of organic compounds. So organic chemistry is the study of organic compounds. What are organic compounds? Organic compounds means which have life. Organic compounds means which have life. As you know that our topic is carbon and its compounds. Organic compounds must contain two elements, that is carbon the most along with the hydrogen. So these two are the elements that must contain in a given organic compound. So we are going to discuss in detail about what are organic compounds and carbon and its compounds topic. Let us study about the basics of carbon. First we must know basics of carbon. So guys, you all know that in the periodic table carbon belongs to 14th group element. First point, very important, everyone make a note of it. It belongs to, it means carbon here, it belongs to 14th group. It belongs to 14th group. You know very well, symbol of carbon is C. Its atomic number is 6. Atomic mass is 12. So once again I'll repeat you guys. Carbon belongs to 14th group. Its symbol is C. Atomic number is 6. Atomic mass is 12. This is the basic study about carbon. Now, what is there to study more about carbon? So that is its unique nature. Carbon's unique nature. Unique means versatile nature. You also know that carbon is the element that is present abundantly in our atmosphere, on the surface of the earth. So in our day-to-day life, carbon plays a very important and major role. Right? Coming to in detail our topic, we should also focus first on electronic configuration. So electronic configuration of carbon. Since its atomic number is 6, I already taught you how to write electronic configuration as per the molecular chart, as per the filling up of the shells. So 1s2, 2s2, 2p2. So this is the electronic configuration of carbon. Coming to the dot structure, so this is the nucleus. First shell should contain, that is K should contain a maximum of 2 electrons. Next, it should contain 8 electrons, but it has only 4. So, therefore, its valency is 4. So, the carbon valency is 4, which means any element that possesses the valency 4 is called as tetravalent. It is tetravalent. Now let us study once again in detail about structure of atom. Atom is a subatomic particle which contains nucleus in its central portion. Nucleus is the combination of neutrons and protons, you know very well. And the particles that are called nucleons. Inside the nucleus, there exist neutrons and protons. Protons are positively charged and neutrons are neutrally charged, which means no charge. And one more very important subatomic particle, that is electron, which always revolves around the nucleus in specified paths called shells. Electron is responsible for bond formation and electron is a negatively charged particle. So this is about structure of atom. Now coming to dot structure of carbon. Carbon, since it contains 4 in its outermost shell, so 1, 2, 3, 4. So 4 electrons are arranged in the 4 respective sides of carbon. So therefore, this is the dot structure of carbon. Dot structure of carbon. So this is the basic thing about carbon. One must know the basics of carbon. It belongs to 14th group. Symbol of carbon is C. Atomic number is 6. Atomic mass is 12. We are studying about carbon in most of our chemical classes, that is chemistry classes, because it has unique character, unique nature, which means versatile. Mostly in our day-to-day life, we find carbon everywhere in the... Okay guys, next let us study how to draw dot structures. Very important for examination. Unless you know the dot structures, you cannot able to predict what is the structure and what is the bond angle between the elements. So formation of O2 molecule. So let us study a formation of O2 molecule by dot structure. You know very well guys, oxygen is the element with atomic number 8. So atomic. So this is the way how you will approach while doing dot structures. Atomic number is 8, which means electronic configuration. Step by step you should follow like this. Electronic configuration of oxygen is 1s2, 2s2, 2p4. So it has 6 valence shell electrons in its outermost shell. Therefore, we represent in the form of dots 1, 2, 3, 4, 5, 6. So since this is O2, let us take one more oxygen. Similarly, 1, 2. I will represent now this with dot because just for our convenience. 3, 4, 5, 6. How this O2 molecule is formed? Let us tell you an example. So you are in a classroom. Your teacher strictly commanded you to use red pen for writing questions and blue pen for writing answers. You and your friend Imagine this oxygen to be you and this oxygen to be your friend. You have blue pen, your friend has red pen. Now what you have to do to make your teacher happy and you also happy? So now you must share a blue pen. The guy who has blue pen has to share his blue pen with the person who is having red pen, and this fellow with red pen has to share with other person who is having blue pen. Now you are somewhere apart. When you sit close, which means when these two atoms are bring close, then there occurs presence of, count these guys, 1, 2, 3, 4, 5, 6, 7, 8. You know very well, presence of 8 electrons in outermost shell is called octet configuration, which means usually the element is stable here if it contains 8 electrons in its outermost shell. So like how you shared your blue pen with others and their red pen with you, finally you complete the task happily. Here after sharing 2 electrons from this oxygen to this, and simultaneously these 2 oxygens also shared by this oxygen. Now we can represent, so here one thing should be very careful guys. 2 electron means a single bond. A pair of 2 electrons represents a single bond. 2 more electrons, it represents one more single bond. And the element that we are discussing is oxygen. Here also it is oxygen. Therefore, what are the unshared or untransferred or unshared electrons? Let you write as it is. So dot 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 dot. So this is the dot structure for O2 molecule. This is O2 molecule. You must be very clear. This is dot structure for O2 molecule. If you are asked to write for O2 atom, you just write simply this and leave it. There your task is completed. So dot structure for O2 molecule is, so this is the dot structure for O2 molecule, and finally where there are 2 bonds, it represents oxygen has double bond. Oxygen has double bond. Right? Clear? I will give you to do dot structure for Cl2 molecule. Very careful guys while doing, as I told you. First you should write the atomic number. Atomic number of chlorine is 17. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p. Here it is 10, 12, 12 plus 5, 17. So what is the valence shell? Outermost shell has 7 electrons in it. Therefore, as usual, let us take one chlorine here. Write that 7 in such a way, 1, 2, 3, 4, 5, 6, 7. To differentiate other chlorine, I will put dots 1, 2, 3, 4, 5, 6, 7. If it gets 1 electron, it becomes stable by attaining 8 electrons in its outermost shell. Therefore, let us bring them close as usual, as we discussed in blue pen and red pen example. So one chlorine, here one dot. So as usual, the unshared will be here. So now this chlorine takes one electron from this chlorine, and as well as here also the chlorine takes one more electron from this chlorine. Therefore, two electrons, a pair of electrons is represented by single bond. So chlorine, chlorine, and what are the unshared electrons here? 1, 2, 3, 4, 5, 6. Same 6 represented by cross. So this is the dot structure for chlorine molecule, Cl2 molecule. Now, where there is only one line, one small dash-like line, it represents single bond. So there exists a single bond between chlorine molecules. What about oxygen? There exists a double bond between oxygen molecule. Right guys, as a homework you do by yourself, write a dot structure for chlorine molecule, F2 molecule. So that is your homework guys. First you should know what is the atomic number of chlorine, what is the electronic configuration, find out how many valence shells are there, draw fluorine on either sides, and whatever the electrons either to be transferred or shared, you do it, and finally see what type of bond it is forming. Right guys, that is your homework. Right guys, next unique nature of carbon, let us see in detail. Carbon possesses tetravalency, which means it should contain valency 4. It contains valency 4, catenation, isomerism, polymerization. Here isomerism and polymerization is not discussed in our syllabus, which means you are going to discuss further in your next level of classes. Let us study about tetravalency. Carbon, since its number is 6, atomic number is 6, its electronic configuration is 1s2, 2s2, 2p2. So it contains 4 electrons in its outermost shell, which means in the first shell it contains 2, in the next shell it contains 1, 2, 3, 4. Therefore carbon is called tetravalent. Now dot structure can be represented as 1, 2, 3, 4. It has 4 valence electrons. To attain stability, we studied in the last class, elements either gains or loses electrons to attain stability. So this is what happened with NaCl. In the last class we studied in metals and non-metals. Sodium is a metal, chlorine is a non-metal. We know very well metals always loses electrons or they donate electrons, and non-metals always takes electrons or they accept electrons. Therefore, Na after losing electron becomes Na plus, and chlorine after gaining electron becomes NaCl minus. Therefore, an ionic bond is formed between sodium chloride by transferring of electrons. So guys, how ionic bond is formed? Ionic bond is formed by transferring of electrons. Whereas in case of carbon, everyone must remember very, very important point. In case of carbon cannot transfer its electrons. Carbon cannot transfer its electrons. Whatever the 4 valence electrons carbon has, which means carbon shares its 4 valence electrons. It shares either simply by carbon or any other element and forms a covalent bond. So carbon forms a covalent bond. So ionic bond means we understood very well in metals and non-metals topic. Ionic bonds take place due to transferring of electrons. But carbon cannot undergo ionic bond. Carbon can only undergo covalent bond, but not by transferring of electrons, but by sharing of electrons. So what is a covalent bond, which is very, very important. So even for the examination point of view also it is very important. A bond that is formed, a bond that is formed due to sharing of electrons. So E minus represents electrons. So is it clear, guys? Now how carbon attains stability? Here, if carbon loses 4 electrons, it becomes stable by attaining nearest inert gas configuration, that is He. He configuration is 1s2. Okay, but you know very well carbon is a small element. Small element means inside the atom. I have already shown, if this is the carbon, element carbon, the distance between the nucleus and outermost shell is very near, which means this nucleus holds the electrons tightly. Remember this point, guys. Nucleus holds the electrons tightly. Nucleus holds the electrons tightly, which means it is impossible for carbons to donate 4 electrons to the other element and attain helium stability, which is impossible. The reason is why? What is the reason? You may get a question like this, guys, in the examination. Why carbon cannot lose 4 electrons? What is your answer? Yes, since being a small element, carbon is a small element in its size. Nucleus holds the outermost electrons tightly. Therefore, it is not that easy to lose 4 electrons. If it gains 4 electrons, what happens? If it gains 4 electrons, then it becomes stable again by attaining inert gas configuration, nearest inert gas configuration, that is neon 1s2, 2s2, 2p6. Therefore, this is stable. Even accepting 4 electrons is also difficult. It is not that much easy to accept 4 electrons at a time, because whatever the nucleus, whatever the protons are there, they cannot take the strength of extra 4 valence shell electrons. So how, guys? So therefore, carbon cannot either gain electrons, carbon cannot either lose electrons. Therefore, it can only share its electrons and forms a covalent bond. So this is all about tetravalency. It's a clear-cut idea. Next is catenation. What is catenation? What is catenation? Catenation is a self-linking capacity. So it is a property of forming long chains. Usually catenation means it is a property of forming long chains. So for our convenience, for our understanding, catenation means self-linking capacity. Carbon is the only element in the periodic table which can form many bonds with other carbons, unlike any other element. I think there is another element in the same group called silicon. It can form only up to 7 to 8 bonds, but not more than 8 bonds. There can be no formation of 10 bonds with silicon. Therefore, carbon is the only element which forms different number of bonds, which we call as branches, chains, or rings. So rings in the sense simply it is cyclic. So I will tell you an example. This is called a branch. So carbon branch, a chain, a long chain. So self-linking capacity is called as catenation. Branches, for example, carbon can also form branches as well. This is an example for branch. Carbon can also form cyclic structures. This is also a property of catenation. This structure is called as cyclic branch, cyclic ring. So, since the carbon is the only element that can be able to form long chains, therefore that property is called as catenation. Carbon can form up to a 60 branched chain, which is called C60, that we call Buckminster Fullerene. The name of the 60 branched carbon chain is called Buckminster Fullerene, which appears to us like a soccer ball. It is otherwise also called as buckyballs. So the other name is buckyballs. So carbon, as I told you, it is the only element in all among other elements that has the unique property. Right guys, next very important even for your final examination point of view. So formation of H2 molecule by dot structure. You know very well the atomic number of hydrogen is 1, its electronic configuration is 1s1. So H2 no, so write one hydrogen here, the other hydrogen here. What is the electron that is containing in its outermost valence shell? That is 1. I will represent with cross. Here I will represent with dot. So here to become stable, it should transfer one of its electron to the other hydrogen and vice versa. So transfer should be taking place here. I will write them close, hydrogen, hydrogen, one cross and one dot. So this cross and dot applies, these electrons applies for both sides of the hydrogen. Therefore, I already told you now, one pair of electrons are represented by a single bond. Therefore, hydrogen, hydrogen dot structure is this. So, this is the dot structure of H2, dot structure of H2 molecule. And what type of bond it contains is, it contains a single bond. So here, while doing dot structure, one thing must be very careful guys. First thing, you must know what is the atomic number and how to write electronic configurations. So simply after just by seeing this, sometimes it looks like a difficulty, but when you practice it for n number of times, then this dot structures becomes very easy. Let us go with next N2, dot structure of N2 molecule. You know very well the atomic number of nitrogen is 7. Its electronic configuration is 1s2, 2s2, 2p3. Its electronic configuration is 2p3. So write one nitrogen here and the other nitrogen here. So, as it contains 5 electrons in its outermost shell, for my convenience, I will write like this. So here, nitrogen, when you bring them together, nitrogen will transfer or share its electrons with either of the nitrogens, and therefore there exists a triple bond. One pair means single bond. So totally there are 3 electrons on either side, therefore it is nitrogen, dot structure of nitrogen. Nitrogen, dot structure of nitrogen molecule is like this. And what are the unshared electrons? We have 2 unshared electrons. Therefore, nitrogen forms a triple bond. You should remember, guys, for examination they will ask you, hydrogen forms what kind of bond, oxygen forms what kind of bond, nitrogen forms what kind of bond. So here it is very important to remember that nitrogen forms a triple bond. And next, NH3. What is NH3? You know very well, NH3 means it is ammonia. NH3 is the formula for ammonia. So let us write nitrogen. The one which is single should be right at the center. Hydrogen, hydrogen, hydrogen on either side. We have seen that there are 5 valence shell electrons in its outermost shell for nitrogen. So for my convenience, I will write like this: 1, 1, 1. So 1, 2, 3, 4, 5. So this is for our convenience. We can write in whatever way we like. So hydrogen contains, you know very well, hydrogen contains 1 electron in its valence shell. So this hydrogen shares with so nitrogen shares its valence electron with hydrogen here, one more here, and one more here. So unshared electrons are 2 here. Now you can write ammonia as N, 1 pair of electron means single bond, 1 pair of electron means single bond, 1 pair of electron means single bond, and unshared electrons should be written as it is. So this is the ammonia dot structure. Dot structure of ammonia molecule. So we discuss the shapes later. Next to last, that is CH4. CH4 is the name of, CH4 is the formula for methane. CH4 is the formula for methane. So the element which is in the least should be written first, and the hydrogens, 4 hydrogens are there. They must be written on 4 sides. You know very well, carbon is a tetravalent, therefore carbon contains 4 valence shell electrons. Hydrogen contains 1 valence shell electron, therefore this hydrogen takes 1 electron from its one side. So similarly, 4 hydrogens takes 4 electrons from all the 4 sides. Therefore, there exist all single bonds between carbon to hydrogen in methane. So this is the dot structure for CH4 molecule. CH4 means methane. So guys, for today's class, we have discovered about the carbon and its compounds. Almost 20% of the lesson we have discussed. We have seen about the basics of carbon. What is the basic of carbon? To which group it belongs to? What is the uniqueness about carbon? We have also seen about the tetravalency nature of carbon. Later we discussed the catenation property, which means self-linking property. Catenation means it is the process of forming long chains. We have also written two more properties on the board, that is isomerism and polymerization, where that is not discussed much in our topics. After that, we have seen how to write dot structures. Dot structures are very, very important for even examination point of view. So, right, this is what today's class. I will see you in the next class, guys. Dear parents, దయచేసి ఈ వీడియోని మీ పిల్లలకి చూపించవలసిందిగా కోరుకుంటున్నాము. సో ఇందులో ఈ క్లాస్ జరగడం జరుగుతుంది. ఆల్రెడీ ఈ క్లాస్ ని మళ్ళీ ఇంకొకసారి చెప్పడం కూడా జరుగుతుంది, బట్ యాజ్ ఏ ప్రీ ఎక్స్పీరియన్స్, యాజ్ ఎ లిటిల్ నాలెడ్జ్. సో ప్లీజ్ డూ షేర్ దిస్. థ్యాంక్ యూ.